Time for another draft physics video presentation. Yeah, so the traditional atom is pictured. Swirly bits, doesn't make much sense. Don't really need to have things swirl around. We know that everything has different properties. If everything was doing the same thing, then things really wouldn't be different, probably. So, atoms are so different in what they create as compounds. Their functions are so different. This model doesn't really provide any mechanism for that difference, when you think about it. Really, geometry is everything. Squares and circles and different things will behave different ways, so this swirly stuff just is completely unnecessary. Anyway, theoretically, don't see any real function for it. So I found this new channel. It's called Physics Online, or Online Physics. Yeah, maybe that's it. Well, I should get it right. It's sort of annoying. Anyway, strange. I mean, perfectly good conventional crapola. He has like 64,000 subscribers, but his view numbers are terrible. So, they're not much better than mine with 2,000. So I don't know what's up with that. Very strange. Can't imagine how you could have so many useless subscribers, unless you purchase them or something. But anyway, just, not saying that's a bad thing to do. Just saying it certainly doesn't work. But anyway, so, I mean, the idea of, doing physics online sounds like a good idea, but there's got to be some sort of, it would be better if the physics was, could accept the critiques they like to dish out. So I'll just say again, they're very good at shutting other people up, but they're not very good at answering any questions. So, it makes them sort of just tyrants. But anyway, so there's one on magnetism. I figure we'll play with it. I haven't watched it. We'll just see what it does, because clearly I'm going to say yes. What he's going to say about a magnet isn't going to make any sense at all, because he's not going to provide any mechanism for this phenomenon at all. That's my prediction. And I didn't need quantum mechanics to predict it. Yeah. No quantum mechanics necessary for that prediction. The gratuitous, I guess it's not gratuitous, because, they have to try to make some money and all that kind of crap. No, I really don't want TV. Lived without TV for like 20 years now. It's done me no harm. Frankly, I can't even listen. I even hear a little bit of TV, or even a tiny bit of radio. I mean, radio's really bad. I don't know how people turn radios even on and survive the experience. It's just talking piles of shit, just talking absolute shit, and then it's 5 trillion ads. It's just so bad. Selling you all kinds of obvious quackery. It's just like radio is just for all kinds of pseudo quackery crapola cures. Little, I can cure your cancer in 5 notes. I mean, it's just, that guy says he can do it in 3 notes, but I don't think he can. Disgusting. Anyway, continue.
So I'm currently filming this video while I'm stood in a field, but I'm stood in a magnetic field.
Okay, stood in a field. I don't know what that means. So it's this British stuff. Maybe that's why people don't watch the videos. It's that British crap. I don't know. What language do they speak over there? I don't get it. Anyway, play along.
And you might see that if you've got a compass, what we have is the pointer here points to the magnetic north. The reason for this is that the Earth's core causes there to be this permanent magnetic field, and actually that deflects highly charged particles that come in from the sun, and actually it means that life on Earth can exist. So we are currently in a magnetic field.
Yeah. I guess there's nothing to say about that. Obviously, the particles have to have some sort of polarity, or they have to have some sort of charge to be deflected. I mean, you'd say that some would end up being converged if they were positively charged, or so they sort of have to be Yeah, frankly, yeah, I've got to think even about that, right? Even about that whole idea of how exactly the charge has to be one charge, because one charge is going to focus them right into you. You know, if they're positive, if this field is, you know, is going to be negative and positive at different ends. Well, anyway, I have to think about that one.
But we also have a region around certain materials where we have a permanent magnet.
I suppose just by random, it would deflect some portion automatically because they're like magnets coming the wrong way. Like even if it's a dipole and it's heading for you, a magnet, and it's heading for another magnet. Well, half of the ones that hit the red end of the Earth, right, are going to bounce off because they're the same pole facing same pole. And if they have enough energy, they don't have enough energy to turn. So if their momentum is fast enough, they're not going to turn, so they're going to bounce off. And then you'd say the same is going to happen to 50% at the North Pole. So it takes away 50% of the problem. But the other half of the problem is the ones facing the right way that accelerate a little bit because of the field. But anyway, okay.
Field. So this thing here is a permanent magnet. We've got a north end and a south end, and we can see how this causes other materials to become magnetized.
You know, become aligned. Yes, it's already magnetized, right? So the compass needle is already, you know, because it's in the magnetic field of the Earth. So essentially, it's already magnetized, and so it's going to flip because it's already magnetized. So it's not going to gain like the iron filings. They gain the opposite magnetism to the magnetism that exists. They don't flip, you know. So it's a little different. You got to be a little more precise. I mean, all these little details are important. You know. It's physics, you know. So, and again, I am drafting, so sometimes I do make mistakes there also. But I'm calling it draft. I'm not saying, oh, I got the right answer. Well, I am saying that. So let's understand this simple argument once again of what really is taking place and how they really screwed it up. And unfortunately, it was Faraday who was one of the biggest criminals in this subtle little crime. All right, because what they knew from charge was, like if I drew two charges, okay, and you could understand I smashed the two charges right next to each other, but they don't discharge. So I have a positive and a negative right next to each other, but they don't discharge. So, you know, this has got 250,000 volts on it, and this has got 0 volts relative to that, or you can just do 100,000 positive and 100,000 negative. There would be a substantial charge, and how Maxwell and maybe even Faraday would understand that charge is they'd understand it as these little lines of force coming off of it. Okay. And they would understand that this is creating the essence of its profile as a charge. So, and there's going to be these areas, okay, where the negative force is going to bleed into the positive, and likewise the positive force is going to bleed into the negative. And they would understand that what you're really going to measure, you know, when I put an electron here, is how much is, or a proton, how much is it repelled by the yellow, and how much is it attracted by the white, and that will define some sort of path it might take to its destruction. You know, it will have to curve around because it's got a little bit of pressure pushing away here, and it's got this sucking in kind of pressure here. And they could draw these little silly lines, but these lines really don't mean anything. They're just trajectories of what things it would take. And obviously if I put a white thing in, I get a completely different trajectory in the sense that it's going to end up just going, it's going to be in real trouble because it's probably going to end up just going this way. You know, it's not even going to be able to do the attraction thing. But anyway, if it did, it would do it this way. It would arc this way in. Because it's got to deal with the repulsion and then be attracted. So it's a balance of these two forces, and you know, this is just classic Maxwellian charge mathematics, where what you do is just create an arbitrary number of these lines, and then you can go any place in space and you'll have the same lines, and you want to know how much charge is out here, you just measure how many lines did I intersect. because the square here will intersect 3 lines, the square here will only intersect 1 line, and it goes on and on. That gives you the inverse square law, and it tells you exactly what the strength of the charge is at any one position. And all you do is just say the strength of the repulsion is +3, and the strength of the attraction, okay, going this way, in another direction, is -2, and you just do your math, and you drop the chalk. So anyway, this is the correct model. Okay, this is what it's actually doing. Okay, these are the lines of force. It's a straight line force. It's proven by the inverse square law. This is what it's doing. It's a straight line force. And what they do, when they get to the magnet, they somehow change the rules and say, no, we're going to follow the path of how magnets line up. So how a magnet lines up, a dipole, okay? So the dipole is going to line up exactly the opposite. When it gets, first it gets, if it's not magnetized already, like a compass needle, then it acquires the opposite magnetic polarity to the object magnetizing it. So it's always opposite in terms of how it's a ferrous material. And the magnet will, just based on the same math as this, all you're going to do is, like at this point, you're going to understand that it has a certain amount of traction for this end, and this end is repelling. And likewise, there's the opposite thing happening to this other end of the magnet, where it's terribly repelled by this end, but it's attracted to this end. So this end is pulling it down, this end is pushing it away, and just based on how strong those two forces are will dictate what angle it's going to be at. Okay, so it's just lining up with the radiation coming off the magnet, exactly like it would line up if I put a magnet next to this too chargy thing. The same exact lines will be created, but nobody would have the illusion that anything is traveling those pathways. Nobody would say there's any force going this way around the magnet. Nobody would do that. And what do they do to magnets? They always draw these stupid arrows on it, and it's not doing that. This is the north end, this is the south end, and they just draw these silly arrows saying that there's some sort of pathway going around the magnet, and no, it's not doing that. And they wouldn't do it if this was a charge. They would know that's not the right answer, and such an obvious error. So this is what Faraday did, is he changed the word, in my opinion, something that was understood as these were lines of force for charge. That's what these were called. And he ended up calling these lines of force. And these are not lines of force. These are, and again, as I've explained, the reason why these lines even exist is because all of these new magnets, or all of these compasses, will swing to the same orientation as the big magnet. So they're going to go exactly the opposite to that magnet. And that means they're going to repel each other here. These are going to be incredibly repulsive to each other because they're in the same orientation. Their positives are hitting the positives, the negatives are hitting the negatives, south, south, north, north orientation. And that's why these lines even exist, is because once a line is established, and it's stronger than the field's going to say, it's going to pull everything this way or it's going to pull everything that way, but it's not going to pull these two together because they're opposite magnets. I mean, they're the same orientation and therefore repulsive, very repulsive. And that's the only reason why the lines even exist. They're completely meaningless to the elemental function. The elemental function is straight line radiation coming off of the magnet. They're light bulbs, essentially. A little north light bulb, a little south light bulb. You can think of it as blue and red, and then think of the mixed force as purple, and then you'll understand that, yes, the purple zone is a little ambiguous. Okay, it's more blue at one end and more red at the other end, so other things can line up with that. So it can be detected. It's not pure purple. I mean, if you're coming from this way, it's more blue, and if you're coming from this way, it's more south. I mean, more red. But you can understand why there's these magnets line up in these positions is merely because of how much blue is hitting their blue end and how much red is hitting their red end, and vice versa.
In actual fact, if we've got this paper clip although the paperclip isn't a magnet, it can become magnetized in the magnetic field, and then it experiences a force. So certain materials like iron, steel, nickel, cobalt, these materials can become magnetized, but other things, for example copper, can't be.
So we know it can be, but it can be in a very specific way, in the sense that you have to actually keep a changing magnetic field, expose it to that, and it'll create a repulsive field back. So if you move a magnet towards copper, the copper does become magnetic, and it creates a opposite field, the same field this time. Opposite to the iron filing, the magnetism induced is not the same magnetism. If I bring the copper in, the north end makes a north end on the copper closest to it. So it, where the iron would turn south-north, the copper turns north-south.
And basically, the region around a permanent magnet where another object experiences a force is called a magnetic field.
Right, but they think the field is doing this kind of stuff. That's swirling around here like cool hyperboloid bullshit. Maybe they even think there's toroids going this way. None of that crap's happening. There's no movement at all except the radial movement, the light coming from the sources, and that's it. There's no other movement in the field except the photons, so to speak, the virtual photons emanating from the north end and emanating from the south end. Blue light, red light.
Now we can actually show the shape of this field because we can't actually see it, but we can show the shape if we were to use some of these iron filings. So I'm just going to
So the iron filings are going to become exactly what the compass needles were doing. So to their length, the longer end will become north-south. They'll turn into a magnet, and the magnet is basically saying, that the two ends are essentially trying to get as far away from each other as possible, so to speak, even though it doesn't make intuitive sense. So it will polarize over its length, and so the iron filing will become a magnet depending on how it's introduced to this magnet, and it will become a magnet exactly the opposite. The north end will imply a south end on the iron filing, and that will cause it to magnetize in that orientation. And it's because the iron is essentially made of a bunch of little atoms that are already magnets, and all you're doing is lining all of those up the same way. So the little magnets inside of the iron filing itself are really just lining up opposite to the original magnet. They're lining up to be attracted, to maximize attraction, and to minimize repulsion. So they line up to maximize attraction, minimize repulsion, and as they all line up, because they're all in the same area, they're getting exposed to the same amount of red and purple, they'll line up in the same orientation, in the opposite orientation to the original magnet to maximize attraction.
Sprinkle these around. And what we can see is that these start to align with the magnetic field lines, and it's strongest at...
So they're not aligning with any real line. Okay, now there are rays shooting out of this thing. So there's these nice little straight line rays, okay, that are coming out, and they sort of look a little bit like that at the tip, right? At the, the ones that are close. But exactly the same thing is happening, okay? The little iron filings are lining up as... oof. So what I'm arguing is yes, there's a bunch of straight line force emanating. And what the magnets, the little iron filings are doing is this is a north end here, so let me put that in the right color. Okay, and so what the little magnets are going to do is go south, north, okay, and they're going to line up with that field. All right, so they're going to keep doing that, and as they're doing that, exactly the same thing as I said before. They're not going to line up on the specific lines. Okay, there's not like 75 little lines coming out of here. There's billions of lines coming out of here. And they're going to line up, and they're going to do the same thing that they do over here, in the sense there has to be an empty space between them, because they're going to repel each other, because they're exactly the opposite to this magnet, and they're exactly the same. So every iron filing is the same orientation of magnet, which means they're repulsive. So these lines, again, are just illusions. They don't have anything to do with a real... These aren't lining up on specific lines. They're just lining up in orientation to the fact that there's a lot of white coming off of here, you know, so you could say the blue, if we had this better oriented. And they're just maximizing their ability to be attracted by bending just right. Now, once they get to this edge, once they're like over here, okay, a little bit out in this space, you can sort of understand that now they're exposed to a little bit of this radiation, okay? So now they're going to be tilted because a little bit of this can reach them, and now it's going to tilt them. And so now they'll start to curve. That's all. That's the simple, rational explanation for what's taking place.
At the poles of this magnet. But we can't really tell which direction that magnetic field is acting. So there's something else that we can use to measure and actually start to plot the magnetic field.
Right, so he just said it, right? He said, what direction? There's no direction. The blue light goes that way. The red light goes that way. There's nothing going around. So, there's red coming off of here, and there's blue coming off of here. But it's all a force, and it just means that, yes, the red thing is attracted to the blue light, and the blue thing, okay, is attracted to the red light, and vice versa for the repulsion, and that's all. And so you're just seeing where things will line up if you create this fake field. Now again, if I put this magnet in oil, I won't get any of this pattern. I'll just get a bunch of lines forming like these, where each little line repels because it's the same orientation, the same magnetic orientation. They repel each other, and you just get a bunch of lines here. You won't get any of these lines because those magnets will smack right into the magnet. So it's only when you have friction to stop the little bits from moving into the magnet that you'll ever even see those lines in any permanent way. You can see them in transition, as like in oil, you'll see them for a moment or two, but they won't be permanent.
Around one of these permanent magnets. So I'm just going to hold this slightly to the side so the fields don't interact too much. But we can also use these small compasses here. So this is our kind of compass for navigation. But this compass here is called a plotting compass. And what you can do is use several of these, and the small bit inside starts to align with the field line. So if I'm just going to take one of these, what you could do is that you put this plotting compass near to the magnet, and then you maybe mark on the paper behind it the direction that this is pointing in. And what you'll see is that as we go from one end and we go round, that pointer keeps pointing in a certain direction.
Right, and it's only pointing just as if the same exact thing in charge. So it's only pointing based on the theory that if you say for the two ends of the needle of the compass, there's a stream flowing out this way and there's a stream flowing in this way, okay, not swirling around, just in and out. And what happens to another dipole, something that has both the attractive and repulsive ends, what does it do? So if I put electrons in that only repel one way, right, they only go into the flow here and they go out this way, and the proton would do exactly the opposite, go away here and come in here, then your lines would be like this. They'd all collide into the sides of the magnet. There wouldn't be any of this all the way around crap. Okay, so it's only because it's a dipole that you're putting in the field, okay, that's a mixed dipole, it has both phenomena are happening at the same time, that has any indecision at all. Because the charges wouldn't have that indecision. They would just collide into the preferential field. This one flow would pull them right in. But obviously it can't just pull them right in when it's a dipole because it has a repulsion to that. Half the boat doesn't want to go that way.
And actually what we find is that the field lines come from the north end, they loop around and they go into the south end.
Complete rubbish. So the only reason why they say this is because of how electricity works. So because one end of the magnet is repelling electrons, the north end, then they know that this end is the push end. because it's pushing electrons. Now, if protons were on the outside of atoms and electrons were on the inside, then they'd say the flow was this way, right? So it's completely arbitrary which way this arrow they place on this field line is. It just has to do with whether you're pushing electrons or pushing protons. Pushing protons really hard to do. Pushing electrons really easy to do. Electricity is completely dependent on pushing electrons, so the arrow goes this way, right? But that's the only reason why that arrow is there. It has nothing to do with anything flowing in this direction. Nothing, nada, zero. No experiment in the history of experiments has ever demonstrated that a permanent magnet has any movement in any frickin' direction around its circumference. There's no evidence of any motion in the downward, in the north-south direction. No evidence.
That magnet. So we can actually start to get a sense of the direction of the magnetic field lines by using a plotting compass, but we can also see it just using iron filings that shows the rough shape of that field. And we've got to remember that this is very much a 2D version of that field. The field is also going to be coming out of the paper and so on. So let's have a look at...
And let's also understand that it only exists because of friction and because the little bits can't just turn and flip and move, because they're stuck on a piece of paper.
Drawing some of the magnetic field lines around a permanent bar magnet. So this is how we can actually draw the field lines around, in this case, a permanent bar magnet. Now, just by convention, we tend to have the north end.
Yeah, just by convention, you happen to just draw something that has nothing to do with the actual reality, because those lines are completely arbitrary. And the only thing that's real about them is there's a real strength to the magnet. You know, it has a real N value in terms of how well magnetized the little bits are of its mass. So the more bits that are magnetized, the stronger the magnet in a smaller amount of space, and then you'll have tighter lines. But that's the only thing deciding where those lines are. And in a sense, it's just, I hate to say it's arbitrary, but they have nothing to do with illustrating what's causing the effect. And you could draw the same lines on a charge, okay, if it were ever possible to get these two charges, something 100,000 minus volts next to something 100,000 positive volts, and smash them together, they would behave exactly like a magnet. And you would know there was nothing flowing around. You would know it's a radial force, because that's Maxwell's math.
Red and the south end in blue. So that's just a bit of convention. And what we then have are these field lines. Now this is a 2D...
So we should say the convention has a bias. I mean, clearly we know the north end repels electrons. It's clearly the negative end of the magnet, and the south end repels proton. It's clearly the positive end of the magnet. They keep bisecting the field. They want to create something called electromagnetism. They want to somehow say electric charge is distinctly different than magnet. And they're fundamentally the same mechanism. They're applying the same blue and red light. That's what they do. They produce the light, the photons.
Representation. You've got to imagine in reality this is in 3 dimensions as well. So we also have field lines coming out, I guess, sort of over the page and into the bottom.
Right, there's no line coming out, there's just the radiation. The radiation explains where the line would be if you put a dipole in the field. So again, they're just measuring the field by putting a dipole in it. If they put monopoles in the field, the lines look entirely different. And if you understand the radiation that's causing the movement, then you would know the radiation is just coming out in straight lines. It's just a light bulb. A little red light at the top, a little blue light at the bottom. The blue light reflects photons, the red light reflects electrons.
So some would be going into the page. Now, what we do is we always draw these field lines going from north to south. So what I'm going to do is just put on some arrows onto these field lines.
Right, to just make a mess of it, okay? So that, again, that's, Faraday was brilliant. I mean, the tons of experiments he did. I don't even know how he got the time to do all this crap. Amazing person, okay? So no picking at Faraday. But it was just a huge, gigantic, colossal mistake for him to start thinking about these lines as being conduits for something, that these are conductors of some kind, and that there's some flow going around a magnet. It's just wrong.
And we can see that all of these field lines, they start at the north end, they come around and they go into the south end. They never cross over. And as we get further...
Right, they never cross over because the lines exist to represent the fact that all of these lines have the same polarity, that they're all the opposite polarity of the original magnet. And so that's why the lines can't cross over, is because the lines are magnets repelling each other.
Away from the magnet, the field lines get further apart. And effectively, the strength of the field is shown by how close these field lines are together. Just a bit like contour lines, maybe when you're doing geography, if you've got contour lines close together, we've got a steep hill. Well, basically what we have is over here we've got a weak field, and at the poles, at the north and the south end.
And these are, they already know that if they were to take a charge and place it there or do something else, it always leaves parallel to those lines. So it always, perpendicular to those lines. So it goes back to being the straight line force, right? See, this is the funny part, right? Because this is another part of their known mathematics. They know this. So it's not like this is some big mystery, but they know that if I do draw these lines, and then I say, where is something going to go? I place it on this surface, it goes in a straight line. Straight line. Perpendicular to this line. Perfectly perpendicular to this line. That's where it goes if I put a test charge on here. So they already know that that's pretty much a reflection of this line that they pretended didn't exist. That's this line working. That's the fact that this is a radial force. So again, and you could tell the intensity of these lines by, again, just measuring how much these lines diverge. Let me just I'll make 10 lines, arbitrary 10 lines off of here. Now we know that's representing a billion lines. But I put the 10 lines out here and you can see the same principle holds. That the further away I go, the less lines you will intersect, and that'll tell you the strength. So yes, you can measure this and say this is the strength, where these lines end up, but that's not really going to tell you the real truth is this, because this is the inverse square law. These lines diverging in 3 dimensions, that's your inverse square law. And that's why magnets behave less than the inverse square. It ends up the R cubed rule, because the white stuff in this example is mixing with the yellow stuff, and therefore that's why it's not an R squared. It gets weaker faster because of the fact that the two forces, the north-south lights. So if I had actually a blue light and a red light, and I put them right next to each other, at a distance, you're not going to see the blue and red anymore. You're just going to see the purple.
We have these field lines getting close together, and that shows that we have a stronger field at this point. So that's how we can actually represent the field around a permanent bar magnet. So that's a kind of staple thing. But what happens if we're looking at maybe the field between 2 different magnets?
So they said that's a staple thing, and it's wrong. So I'm just saying, once you make a mistake, this elemental, right, then you just pile on more and more mistakes. You've got an elemental wrong understanding of how it functions. It doesn't have anything to do with those lines. It has to do with radial force. Period. All red means lots of segregation. It means it's very potent in repelling electrons because it's not mixed with any of the south end. No blue. That's why this is stronger at the end here, is because there's no mixture at all. You have a little bit of mixture, a little more, a little more, a little more, obviously more and more mixture. Weaker, weaker, weaker. Because now you're pushing and pulling on any test charge. And that's all. That's all there is.
So now we have 2 separate magnets, and we've got the north and the south end pointing to each other. And therefore there's going to be this attractive force between them. So what does the field actually look like? Well, let's kind of model this with these real magnets here. If I just put them there, they're not going to attract too much. Again, to show the direction of that field, we could be using a plotting compass, but I'm just going to use some of these iron filings again, and we can look at the field lines now between them.
So this is just what the magnets do in lining up. Obviously on one side they're going to be oriented north-south, and the other side is going to be south-north. So there's going to be a conflict right in the middle where the two magnets are now going to be compatible side to side. So the lines are going to do exactly what it looks like they're doing, right? It's like one line from this side is sort of smashing into a line from that side, like that. Because now they're not repelling each other. So the lines won't go in any continuous way. They'll always in that middle, there'll be this part where they have to overlap because they're changing polarity. So where they would be repulsive end on end, right? All I have to do is overlap, and I can do that with real magnets, right? Real magnets, I can take two real magnets, and I can just overlap them, okay? And then they'll stick to each other, and I can make a chain. But that's all, I have to overlap them. Just a half. I have to do like a half wavelength of the magnet, right? I do a half wavelength, and they'll be okay. They're compatible now, because now I'll have north end to south end. No, I'll have north end to south end if I have to go full wavelength. Yeah, a full magnet across. All right.
What it's quite clear to see, first of all, is that there's this really strong field between the poles, and actually there's going to be...
So there's no strong field between the poles, okay? The red light's shooting out of one end, the blue light is shooting out of the other end, and there's no connection to the two except for the fact that obviously right in between them you're going to feel the fact is that if you're a charge, you're going to feel all attraction this way and all repulsion that way. So you're going to go really fast this way, or you're going to go really fast that way. But that's all there is.
The field at each end, and it's this region here which is really important. What we have actually between them are these sort of parallel lines where the iron filings have lined up. And actually, if I was to draw this onto the diagram below, what we can do is maybe use our...
So I guess they're not parallel, and that's what you saw. That's why you see it. That's why you don't see it as continuous. It's because they're not parallel, because they have to overlap to connect to each other.
Ruler to show that between the poles over here, I'm just going to do 3 lines. And the lines I'm going to draw, the rulers are nice and straight. I'm going to make sure that they're evenly spaced. And what this then shows is that we have the same field all the way between these two poles of the magnet. This is what we call a uniform field. And again...
Well, it's uniform because no matter where you go, you're going to be... The further away you go from the south, like if you're a proton, right? You're going to go far away from the south pole, and you're going to go as close to the north pole as possible, right? So the strength of the pole gets stronger the further away you go from the push. So the further away you move from the push, the stronger the pull gets, and the further away you go from the pull, the opposite for the negative charge. So it just says that it always equals the same. You're either getting pushed by 9 things and pulled by 1, or you're getting pulled by 9 and pushed by 1. So the push-pull is always even no matter where you go. No matter how close you go to the end or how close you go to the south, it's always the same amount of movement because there's just as much pull as there is push. Now, there is no pull. Obviously, I was arguing theory. And it just has to do with the fact that the charge, that's what charges do. They repel one thing and they attract to the other, but the attraction is, an absence of pressure. So you have, the pressure is always equalized no matter where you go in the field, because you're getting further away from something, the low pressure, as you're getting closer to the high pressure pushing you.
I'm just going to put the arrows to show the direction that goes from north to south. In actual fact, I suppose if we were to do the complete diagram, we could show that there's still going to be arrows that go from the north pole here and they loop around to the south end over here. It's a bit like one massive bar magnet in effect. But this is the field pattern that we get between the poles of magnets, especially when they're attracting. So there's some of the field lines around permanent magnets, but sometimes it's more useful to have a magnet that you can turn on and turn off. And what we then have is an electromagnet. An electromagnet is when you've got a conductor, for example a piece of wire, that has a current in it. When that's happening, we then get a magnetic field around the wire, and therefore we have an electromagnet.
Well, it's a pretty bad example because electromagnets are pretty much fundamentally dependent on the core. So if you just coil a wire, you're going to have a really lame magnet because you're not magnetizing enough ferrous material. You're just magnetizing copper or some other kind of wire, and the wire doesn't hold a permanent magnetism. It doesn't have a bunch of mass to create magnetism out of, and so it's very weak, but it's very good at magnetizing iron. So if you put iron in the core of it, that will be a strong magnet. But without a core, it's lame as hell. Alright, so that was pretty poor. I don't know what GCSE means, physics. I mean, because it was almost like a 6th grade class. And again, but as stated, the theory is just, there's no explanation at all. No getting to exactly how this repulsion and attraction works. No explanation of where the energy comes from to move the iron filings. No, to move the compass needle. No explanation of any of the elemental function. And they're satisfied with that. They think they've got it. Oh, it's just good enough. It's good enough for us to propagandize and state this is what you should believe, even though they have left out all of these important details, like where is the energy coming from, what tells the atoms in the iron to move, what's compelling them, bent space. I mean, what what magical fairies are pushing it one way or pushing it the other way, and they don't have any explanation. Just a fact. All right, so maybe it's 10 o'clock. Maybe the science conference thingy is available for a brain hurt, and maybe I'll pause for a minute. Maybe. I should be back. So let's try some of this. It's probably gonna hurt.
As you enter the buffet area, they have a washing station. So you're supposed to wash your hands before entering the buffet area. But if you go on Norwegian, they have they actually have a guitarist, and then they'll sing you the happy washy washy song as you go by. The coronavirus can actually only attach to the lining of your lung and your lung cells. The virus is very much like a lock and key, and the only lock it can go to is in your lungs. So I have heard some things saying that one of the symptoms for coronavirus is that if you have a very strong hacking cough, but actually no nasal congestion, is that the virus actually has to get into your lungs. So I'm not sure whether we have to worry too much about, say, our eyes.
Well, obviously, most of these flu viruses, have areas that they find, more permeable than others. But once it's in your nasal cavity, it's going to get to your lungs anyway. So if it can survive, and that's the whole point, right? It's only lives because the cell that carries it is alive. So if the cells kill the cells, then you kill the virus's survivability. And so all you're really saying is a cell has to be connected to a water droplet, and you have to inhale the water droplet. But once it gets into your nasal cavity, that cell's probably going to reproduce, and therefore you're going to inhale it into your lungs eventually anyway. So even if it doesn't infect your nasal cavity, it really doesn't matter. It's going to get to your lungs eventually. Unless you just breathe through your mouth or something, I suppose. But then it's a direct route to your lungs anyway. So if that's
not in the neighborhood yet.
Well, it's definitely in my neighborhood. It's like the nursing home that's been mentioned in the news, Life Care Center in Kirkland. That is the center that, say, my mom uses to get her rehab, and we typically go there like once a year. So I've been inside that facility many, many times. So it's kind of scary that we have now basically all those people trapped into that facility, I think. Has completely shut down classes, and they're going to...
So whatever, it's coronavirus, not terribly interesting. Obviously, flus suck, and this is pretty much just another flu, and they'll eventually figure out how to, stick a bunch of virus into eggs and grow a bunch of, flu shot. If it doesn't evolve too quickly, blah, 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 blah. I'm figuring that once the geese get it, and they start dumping it everywhere, then it's going to be all over the place. But it's, almost summer, and, viruses don't do too well because the little water droplets evaporate. And so it's less dangerous in the summer. So anyway, I really don't want to do coronavirus hysteria bullshit. Uninteresting. Not physics. Not really. Biology stuff. Might as well talk about how stupid humans are and that they're dumb fucking robots. It's not really the same subject. Close, but not the same. Alright, so we'll call it a video then. I don't think the comments have been... obviously the troll has less energy. I guess he's got to make some new fake accounts and all that kind of crap. There might be one comment by this asshole. Oh man, so I'm sure that's a real one. According to Poplar, the implausibility of GR is actually what makes it a good theory. Okay, then he's obviously a lunatic, frankly. Oh, implausibility makes something more true. The more implausible, the more true. Yeah, sure. Because if it's not true, then you would expect lots of ways to disprove it. There are lots of ways to disprove it. They just haven't bothered doing the experiment. Again, you can disprove it tomorrow. Just take one satellite, one, with a half-decent camera. One weather satellite that's taking pictures of the Earth, but that's a good enough camera. Just drift it over there, take a little picture right there outside the corona of the sun at that wonderfully little black space and take a frickin' photograph. Okay, a little time-lapse photo, and you'll see the little stars are going to be in exactly the place they're supposed to be. They're not going to be anywhere else. It's going to be exactly where they're supposed to be. There, disproven. Eddington's experiment, which you dishonestly claim, so you're just getting blocked. I mean, I don't dishonestly claim a motherfucking thing, you lying sack of fucking shit. Anyway, claim has never been replicated. Never been replicated with Eddington's technology, okay? It hasn't been replicated with 1919 technology. All right? I mean, it really hasn't, okay? This stupid amateur using a fucking 2-foot telescope, okay, it wasn't even a reflector, is hardly the same experiment. I mean, why did Eddington use a 12-foot-long telescope? Why did he drag a 12-foot-long telescope to Africa and South America if he didn't think, well, you really do have to have a decent telescope to do this experiment, You really have to see thousands of stars, not 43. Oh, you people are so pathetic. All right, anyway. It is just one of the thousands such experiments. Thousands? Oh, shit. You people are just so... How dare you call somebody else a liar when you say something like that? It's just such a pile of shit. There are not thousands of experiments. Where are your thousands of experiments? Again, I plead, you assholes, for links to your fucking beautiful science, your proof science. Show me your proof. It doesn't fucking exist. Try looking up. No, you try posting the fucking link. I've already tried to find your fantasy proofs. They don't fucking exist. Yeah, I've already done... look, they do this test of general relativity. I've already read the tests. The tests are... oh, well, we have this radio interferometry experiment that has all these huge complications, all this huge technology, right? And we claim that we can filter out scatter with our magical filter out scatter theorem. There's no real experiment there. There's no real evidence of anything. There's no photographs. Again, you just keep sitting there. We took a picture of a black hole. We've detected gravitational waves. You keep claiming things for which you haven't in any way demonstrated any volume of evidence, any corroboration whatsoever. Do you really think LIGO can measure half the distance of a proton? Do you really believe that, you fucking lunatic? They haven't done one experiment. Not one. They haven't done anything to show us how sensitive this stupid machine is. Not one fucking demonstration of, wow, look how sensitive it is. All right. That might be a good place to start if you want to learn. Yeah, right. Learn what? Where is your proof? Where is your dramatic fossilized dinosaur. Where is anything like a proof? It doesn't fucking exist, you wanking piece of shit. Okay, that might be a good place. All right, your science, on the other hand, is untestable. That's another bullshit word. It's just as falsifiable as your fake concepts of virtual photon, bent space, dark matter, dark energy, entanglement. I mean, every fucking thing you claim to be true is a fantasy that's unfalsifiable. How do I falsify LIGO's fake claim? I can measure half the distance of a proton. How do I falsify that? Ugh, you fucking lying sacks of shit. Alright, egg. I mean, they can't even come up with some kind of screen name that means anything. The reason general relativity is testable, again, no way have you tested anything. The fact that velocity breaks clocks, I'm not disagreeing with. You prove to me somewhere that somehow the clock isn't broken, that time itself is different, and the clock is measuring the real slow time. Yes, prove that, asshole. That unfalsifiable pile of crap as an assertion. You have an extraordinary claim and you have less than ordinary evidence. It's because it makes predictions another lie, okay, that are different than Newtonian mechanics. Well, I mean, Newton wasn't telling you what velocity does to objects when you give them high velocity, right? He certainly couldn't do those experiments, nor can you. Okay, so you're just claiming you know the magical answer, even though you have no experiment demonstrating you know any such answer. Okay, if you were honest, you'd admit the system predicts things different than both Newtonian mechanics and relativity. There's no point in talking about these silly predictions, because the causes and the effects are completely disconnected. Again, the fact that velocity would disturb matter, okay, has nothing to do with you claiming there's a fourth dimension called time. Those two claims don't have anything to do with each other. Velocity breaks clocks. That's it. That's all the evidence shows. Let's see. You're lying when you say it hasn't been tested. I never said those words. I said it's never been proven. It's never been demonstrated with any volume of evidence indicating that you have enough evidence to assert it as a fact, that time is a dimension. You have no evidence demonstrating this dimension of time. Okay, there is an entire Wicca, so he's citing the same crap. Also, GR is, so I might as well go to that page again, right? And we'll do it again. We'll do another video on these silly claims that we've proven it. Also, GR is used in GPS. So again, and where's, I'm not making any counter argument to that. I'm saying perfectly clearly, the more gravity you're in, I'll play it. The physics guy has a video, right? The one I just did. He has a whole video on the fact that the Earth is pushing back up. Anything you push down on, anytime you try to push on, well, he doesn't say it this way, but see, the electrons on the surface of the Earth are in balance. Gravity's pushing them one way, they're being repelled by the other electrons in the Earth, and they're stuck in a nice equilibrium. And so anytime you disturb their equilibrium, you're obviously going to get pushback. They're not going to say, oh yeah, please disturb me. No, they're going to spring right back because they're going to go into more force. And when they go into more force, they have more force pushing them back up. And so, yes, so we're sitting here bouncing in gravity. And the more gravity you're in, the more you're bouncing. Okay, the faster the rate of the bounce. All right, so that means the more distance you're traveling. There, it's just a velocity question. I'm moving much faster than the satellites because I'm bouncing a lot faster than the satellites are. So I'm covering a lot more distance in real terms. There's the explanation. We're done. Your proof sucks. There's the reasonable counter argument to your nonsense theory. Also, GR is used, okay, we already did that, and they take into account the effect of gravity. So this is more nonsense because they don't use any mathematics. Like, look, a guy who made millions of dollars in GPS, in farming, concedes he doesn't use mathematics to adjust clocks. Okay, so you're just so full of shit. Not just velocity. So the clocks are just breaking due to velocity. Yes, they are. So you have no evidence that's not what's doing it. These people are so fucking dumb, and yet they make these assertions that they know what they're talking about. He doesn't know that gravity is an accelerating force, that gravity creates velocity. So he doesn't understand that's the fundamental function of gravity. Guess what? Even though this is called acceleration, it's also velocity, asshole. Do you understand this piece of chalk has velocity now? Fuck, what a dumbass. All right, due to velocity. Are all these engineers and scientists lying? No, they're stupid fucks. Okay, they're dumb dupes. And they put on their, just like the Roman Catholics or something, they put on their little bishop hats and their little bullshit, and they play their little fake game. They don't really believe in this bullshit, but they know this is sells to people, and this is what people want to hear, and they really have no clue. I don't know, maybe half of them are praying to Muhammad. Who knows what they're doing? All right, but they don't know what they're talking about. They're just regurgitating what they wrote in their little book. This is our book of physics. They have this little lame, silly idea that magnets have swirly bits around them. They don't really think about it. Oh, man, how much sense does that make? Atoms have electrons spinning around them, and then the atoms connect to each other somehow. Somehow they share an atom that's an electron that's buzzing around all over the place. They don't care that it doesn't make any sense. They're assholes. They're idiots. They're fucking doopy little nerds they're idiot savants. Okay, they can do some things really well, but they can't do anything called like reasoning very well. They can just do math. So fuck you in the ass. I haven't lied about anything. I've exposed your silly fables and fairy tales for what they are. Silly stories told by idiots. So here's another comment by Egg. No, all things you mentioned have been observed in labs, so this is more crap. Have you ever heard of Hume's problem of induction? So whatever that is, but I'm sure it's not really a problem. It's a problem in their stupid model. I'm sure a rational model has a simple answer. Just like the Kashmir effect. I mean, it's so fucking obvious. You smash two plates together, what are they doing? Well, the electrons on the surfaces are saying, I don't like this, I don't like this, I don't like this. And when you get to a certain point, the electrons on one of the surface are all going to take off, and it's going to become a positive plate, and the ones on the other side are now going to say, and they're going to move forward, and one side's going to become positive, and one side's going to become negative, because that's what magnets have to do. If I did the same thing with magnets, I push them closer and closer and closer together, their repulsive ends. Sooner or later, they're going to have enough energy, and one side is going to flip. The little magnets are all going to flip. All right. Of course, not like whatever that is, Gary drones. You don't read. If you did, you might understand that Karl Popper was doing when he created the falsifiability. What is that word again? I just can't. It just doesn't. It is funny that there are like 5 words in the English language that I just can't do. Citation, no, it's not the right. It just keeps wanting to turn it into some other word. Anyway, this is funny. Anyway, criterion. There it is. God. So again, it's not a criterion. It's just a silly, wimpy pile of crap. Any theory, okay, has to be judged based on how well it meets the evidence, and again, how simply it meets it. Now, obviously, the theory of this falls down because the bent space fairies push it down is kind of silly, okay, compared to a theory that would say, yes, there's a bunch of energy in the universe pushing everything into everything. Yeah. So this stupid Skyrim douchebag. There is a diffraction pattern of electrons observed with only one slit is open. So, clearly saying diffraction pattern when it's bars is being a liar, frankly. Because we know diffraction just means spreading. Doesn't mean bars. All right? Bars are implication is that has to be interference. The implication of bars is interference. Spreading is diffraction. So quit using the wrong fucking word, liar. Okay, electrons observed when only one slit is. However, the constructive interference is much stronger. Who cares? The fact that there's interference is your problem. The fact that there's interference means that somehow the one thing that went through the slit turned into two things. It didn't need two slits and didn't have to decide to turn into two things. It turned into two things when it went through a single slit. That's the problem you have with your silly wave theory. Waves don't do that. It doesn't make any sense. You can't say that in a single slit over here makes two waves, and then double slits over here only make two waves. If there's two slits, then there should be four waves. All right. It's much stronger, blah, 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 similar to the light. So again, this is just horseshit. You say so. Show me the experiment. Okay, I'll say that first. So the vertical lines of the electron displayed in Veritasum's video was not realistic. Well, that's exactly my point. So you're saying that's okay, though. They keep hyping this lie that single slits don't do anything. Now, that's a lie, isn't it? I mean, they're scientists. They know, right? If I was to say it, if I was to walk around to prove my theory, and so to prove my theory, I'm going to assert that single slits never produce interference patterns. You'd all sit there and go crazy. How dare you, you flat earth science denier? Yet they can do it all the fucking time. You're not calling him a science denier. He's completely perverted the truth. He's misrepresented it entirely for the purpose of making an argument that somehow you need two slits for this phenomenon to happen. He wants you to believe that the electron splits in two for some reason. There is no fucking reason in the single slit. The important part, no, you're fucking missing the important part. The important part is their fundamental theory doesn't fit. That's the truth. The evidence doesn't demonstrate it. It isn't consistent with the experiments. And they are faking the truth. They are distorting the truth. They are quote mining the experiments to prove their argument. They are violating one of the fundamental rules of having integrity when you're doing science. Don't be a fraud and a fake and a phony. Don't quote mine the evidence. All right. Unrealistic. The important part, fuck you, is that when you use a second slit, you just don't get two big vertical lines and a few very small ones. So again, you keep saying, oh, there's just a few interference lines, so somehow a little bit of interference is okay. I can explain that. There aren't two electrons creating it. No, you don't need two electrons to create a little bit of interference. What a pile of horse shit. I mean, you're just sitting here lying about the evidence again. It either is interference or it's not. You can't play this game, it's only a little pregnant. Oh, fuck. Very small ones like your vague explanation would suggest. So again, that's just bullshit. There was nothing vague about the drawings I did. There was nothing vague about my accusations, you lying piece of shit. But multiple lines that represent the interference pattern observed in the original double slit experiment. So you keep saying it, whatever the original double slit experiment is. Okay, first off, Young's experiment didn't show the two patterns. Okay, it was a crude piece of shit experiment. It wasn't even done with monochromatic light, for fuck's sake. So you didn't even get any consistent bars, obviously. You got little circles that are blended into each other in different colors. I mean, you people are just such lying sacks of shit. Just because the concept of wave-particle duality is unintuitive. No, it's fucking silly. It's fucking silly. Right on its face, it's just a Jesus theory. You're just making up a pile of crap. There is absolutely no reason for me to believe anything in the physical universe is duality. Oh, I'm waving and I'm particling. I'm waving and I'm particling. It's just horseshit, and there's no elemental theory of any fucking goddamn wavicle. It's a nonsensical, it's just like saying the universe is made out of jellyfish. Little jellyfish is the universe. It's a fucking silly explanation. Anyway, it's not that it has anything to do with intuition. You have no evidence, and it's extraordinarily silly. You have no evidence and extraordinarily silly. It's worse than religion. All right, and pretty much everyone else doesn't mean that it isn't real. Well, the fact that you don't have any good evidence and it's silly is really good reason for me to say you're just trying to make it true because you want to believe. You're the one with the huge, gigantic bias boner for your little waving jellyfish. It is not the goal of science to give intuitive No, the goal of science is not to be a dishonest cunt. And I pointed out the dishonesty. You can't describe the actual circumstance. The single slit in water does not create interference. Fact. Where do they point that out? Nowhere. The multi-slit in photons creates fucking images. Where do they state that and explain how that's possible with any kind of randomizing jellyfish? How do randomized jellyfish fucking create images? You fucking lying piece of shit. Why don't you answer one of my fucking questions, you fucking lying sack of shit? Doesn't mean that it isn't real. It's not the goal of science to give intuitive explanations. Oh, it appears that your goals and the goals of science are to be propaganding liars and pretend your evidence is conclusive when it's not even fucking goddamn close. If you were lawyers in a courtroom, everybody would be calling you shyster. Okay, because of the dishonest way you present the evidence. Well, look at this bullet. It's flat on this side. What if the flat end, okay, was shot out of the gun, right? How much harm could that little flat end do? I mean, you're just bullshitters. Fucking goddamn pieces of crap. Anyway, the transistors, what the fuck are you talking about? In your computer are designed using QM. That's a fucking lie. Another one of your just pull out of your ass pieces of shit. The fact is that the transistor, just like the CPU, just like the blue LED, quantum mechanics, nowhere in fucking goddamn sight. It was incrementally developed by just saying, hey, this thing gets too fucking hot. How can we make it less hot? That's all, okay? The fucking goddamn photoresistor was essentially invented by Einstein when he discovered the photoelectric effect, okay? In a sense, they already had the photoresistor, okay, which was already a semiconductor. Based on how much photons hit the material, you conduct more electricity, right? That's the essence of the transistor right there. And it took decades for them to do this. They didn't use quantum mechanics. Quantum mechanics didn't show up and say, oh, here's your answer. No, that didn't happen. You people are just such scummy liars. Oh, disgusting. Having said that, there's room for interpretation. No, there's no room for misinterpreting the fact that you're a biased liar. All right, I think that pilot wave theory could interest you. Why would it interest me? I've made it so fucking clear. Your wave is completely fucking perversely disgusting to me. I mean, it is an act of insane silliness that little wavicles are running the universe, that these little jellyfish are at the core of everything. You're making the pressure coming from the outside to from the inside out. Makes absolutely no sense. What's happening in the universe is the energy is going from the outside in, and that's the obvious fact. And the fact that you people are in such denial because you just want to invent a god, and you'll settle for a jellyfish. You're so desperate for a god, but you'll settle for jellyfish. Oh, jellyfish run the universe. They make all these random choices. Fuck you. Okay, it's deterministic. It doesn't rely on observers. Well, it doesn't matter. It's still silly. It's not real energy. It's this fake superimposed nonsense wavicle bullshit. There's no fucking interference, as I'm pointing out. Photons do not interfere with photons. They don't hit each other. They don't interact. It's just a pile of shit that you idiots think that somehow they go through space, mingle with each other, and then decide to go someplace else because of their mingling. It doesn't fucking happen. It doesn't happen with gravity, doesn't happen with electricity, doesn't happen with magnetism. None of these forces do that bullshit. There's no hyperberloids flying around magnets. You're just deluded sissies. With a bunch of sissy plans for the world. Ugh. Disgusting. Unscientific. Okay, the link provided by physics novice is more unscientific garbage. Just a heads up. So here we go. How do you explain... Oh, Bill Gates is kind of full of shit. So yes, I would say no point in posting Bill Gates videos because he's just as big a cheater in the arguments. Huge cheats and lies. Well, how do they explain the photon speeding up? They don't have to. It's not their theory the photon actually slowed down. God, people are such pieces of shit. I was watching 2 UK news channels more than less simultaneously that day and was struck by the fact that the BBC channel was lagging 15 or 20 minutes. So what does that even mean? And the second tower had already collapsed on ITV. Oh, okay. So yeah, so they're just playing a game. But I mean, this is already probably proven stuff. So again, we're not gonna do truth or crap here. So I'll leave it up for a little while since you wrote all this crap. But I mean, clearly there's no good evidence of any inside job theories. They're all crackpot shit. Every single one of them has been debunked numerous times. It's just a pile of shit. And it's people they won't let go of it. It's like their UFO theories. You debunk, and they'll just keep bringing. What about crop circles? Oh, fuck you. Alright, anyway, enough. Get the hell out of here. World's just too fucking stupid. People. Humans suck. They're so dishonest. So fucking goddamn unprincipled. Oh. Ugh.